Okay, so firewalls. Firewalls are designed to prevent specific types of information from moving between the outside world, the untrusted network, and the inside world, or inside your organization's network, or referred to as a trusted network. And if you think about a firewall, it really does create those zones of trust. Anything outside the firewall is considered an untrusted zone, and anything inside the firewall is considered trusted. Firewalls can come in many different forms. They can be a separate computer system. They can be software services running on a particular device. A firewall can also be a separate network which has a bunch of different supporting devices inside it as well. Five basic processing modes by which firewalls can be categorized. They can fall under packet filtering, which is probably the most common, application gateways, circuit gateways, MAC layer firewalls, and then hybrid firewalls as well. Other ways that we see firewalls classified sometimes as far as the developmental era, whether they're first generation, second generation, so forth and so on, and then their intended structure, gateways, so forth and so on. Packet filtering firewalls is probably the most common, so we'll talk about those first. And really they're designed to examine the header information of a data packet that comes into the network. Restrictions are most commonly implemented based on a combination of source and destination IP address, whether it's an inbound or outbound communication stream, the TCP and UDP source and destination port requests as well. Simple firewall models, a simple packet filtering firewall model will examine one aspect of that packet header, whether it be the destination, the source address. They can enforce restrictions, rules designed to prohibit particular packets from within certain addresses or particular addresses from passing through the device. This is accomplished through what's referred to as an access control list, and these are created and modified and maintained by the firewall administrator, which is why I said and referenced that we just don't put a device in place and assume that it's all right. We have to constantly maintain access control lists because business needs are going to constantly change, and therefore we're going to have to update these as well. And of course there are three subsets of packet filtering firewalls. Static filtering, which requires that the filtering rules governing how the firewall decides which packets are allowed and which ones are denied are developed and installed. Dynamic filtering allows the firewall to react to emergent events and update and create rules to deal with those events. And then stateful inspection firewalls or stateful firewalls keep track of each network connection between internal and external systems using what's referred to as a state table, which really tracks the state and context of each packet in the conversation by recording which station sent what packet and when, and usually associated with that is some sort of time to live or how long that packet is allowed to exist on the network. Simple packet filtering firewalls only allow or deny certain packets based on their address. A stateful firewall can block incoming packets that are not responses to internal requests, so we have a little bit more ability to manage those connections. And with each advantage, then the advantage to a packet filtering firewall is it's very light on resources, it's very fast, can handle a lot of traffic. The primary disadvantage is that when we look at particular types of attacks like denial of service and distributed denial of services, if we're using a state table, stateful inspection packet, a stateful inspection firewall utilizing a state table, they are more vulnerable to denial of service or distributed denial of service than perhaps another type of firewall or packet filtering firewall. I'll give you a little picture of a representation of a IP packet, and basically what we would look at as far as packet filtering firewalls would be, destination and source IP address are important, as well as we can also use things like protocol, HTTP, FTP, so forth and so on, are the actual probably the three more common types of fields that are used in the packet filtering. But you can also do it some filtering based on flags as well. And then I shot in here TCP packet structure, and you can see that it's the same basic concept: source, ports and destination ports where we can filter by ports, and then as well as some flags that we can also do in the TCP packet structure as well. And down on the bottom is a UDP datagram structure, same basic concept where we can filter by source and port and destination port. And here's a sample firewall rule and format. Looking at a packet filtering firewall, 3 simple rules, and this is not a complete list, and I'll show you a complete list a little bit later, and you'll realize what's missing. But so yeah, source and destination IP address, the service type that is can be filtered by, and what we're going to do with it, allow or deny. So first rule stream, source IP address 172.16xx, representing any IP address from this particular IP address, looking for any internal network, a 1010 series, using a non-routable IP address, so typical of an internal organization's network. Any type of service, we're going to deny it. So no traffic coming from this particular IP address range, looking for this particular IP address range. Doesn't matter what they are, going to be denied. And then we have a 192.168 range, looking for 10.10.10.25 using HTTP. We're going to allow that, so we filtered it by source address, destination address, and service. We're going to allow it. And then a particular IP address within the 192 range, 192.168.01 to 10.10.10.10, using FTP service, we're going to allow it. So we can use very general IP addresses, X representing a wildcard, representing anything, and then we can block it. We can do a range to a particular IP address, and we can do particular IP addresses to particular internal IP addresses using services, whether we're going to allow or deny. Next type of firewall that we're going to briefly mention is the application gateway. Application level firewalls or application firewalls are usually installed on a dedicated computer, separate from a filtering router, but it's commonly used in conjunction with a filtering router. Also sometimes referred to as a proxy server, since it usually runs some special software that acts as a proxy for service requests. You typically see this in organizations when they want to provide web access to their internal clients, and rather than having all the internal IP addresses bouncing out to the internet, they'll use some sort of proxy or application gateway as a buffer between the internal IP address and the internet. Additional filter routers can be implemented behind the server, which again limits access to more secure internal systems and provides additional protections of the internal system as well. Circuit gateway firewalls, they operate at the transport layer of the OSI model, and connections are authorized based on IP address alone. Just like filtering firewalls, the circuit gateway firewall do not usually look at data traffic flowing between one network and another, but they do prevent direct connections between one network and another. And they accomplish this by creating tunnels connecting specific processes or systems on each side of the firewall, and then they allow only authorized traffic, such as specific types of TCP connections, for only authorized users in these tunnels. Next type is the MAC layer firewall, designed to operate at the media access control layer of the OSI network model. And while they're not as widely or well known or as widely referenced as firewall approaches that I previously mentioned, MAC layer firewalls are designed to operate at that OSI network model, and it gives the firewalls the ability to consider the specific host's computer identity in its filtering decisions. So in other words, in order for an organization to utilize a MAC firewall, what they have to do, or what they would have to do, is the MAC addresses of all the devices would have to be registered with that particular firewall in order for that particular device to access the network. It's really secure. You're basically creating an access control list of all the MAC addresses of any device that wants to connect to the network. As you can imagine, this creates a lot of work for the firewall administrator. Every device that wants to access has to be registered, which means somebody has to manually configure this access control list. anything else, all other traffic is blocked. So if there's no MAC address associated with that particular request for information, then no information is going to be gained. And also, if you're trying to connect to that network with an unregistered device, you're not going to get access to it as well. Firewall types and OSI models. I had mentioned each model type and each firewall type and what level they operated at in the OSI model. 7 layers to the OSI model, application being the one closest to the user, presentation, session, transport, network, data link, and physical as we work our way down the stack. Application gateways work closest to the user. Circuit gateways work at the transport layer. Packet filtering at the network, because we're looking at network technology or network material there as far as IP addresses and so forth. And then the MAC layer works way down at the data link layer. And then the next type of firewall that we would just briefly mention is this, what's sometimes referred to as a hybrid firewall, where they take elements of different types of firewalls, like a packet filtering and proxy services, or packet filtering and circuit gateway, and create a hybrid system. Sometimes these things consist of 2 separate firewall devices, each separate firewall system, but they're connected so that they work in tandem with each other. You see these frequently in enterprise networks. I mentioned earlier that we can categorize firewalls by generation. First generation are static packet filtering firewalls. The simple networking device filters packets according to their header as the packets travel to and from the organization's network. Second generation firewalls are application level firewalls or proxy servers. Again, these are dedicated systems that are separate from filtering router, and they provide intermediate services for requests. Third generation firewalls are stateful inspection firewalls. They monitor network connections between internal and external systems using state tables. Fourth generation firewalls are the dynamic packet filtering, and they allow only particular packets with a particular source, destination, and port address to enter. And then the 5th generation, and I didn't put an example up of this, but these are kernel proxies and specialized form that works under the Windows NT Executive, which is the kernel to the Windows NT system. I'll give you a little example of a state table where we have a source IP address of 192.168.2.5 with a source port of 1028 going to a particular internal IP address of 10.10.10.70 on port 80. And you'll notice that the total time in seconds is 3,600 seconds, and it's using a TCP protocol, and it has a designated time remaining of 27.25. And this is how it would maintain that connection. And imagine that you would have a much larger state table depending on the number of number of devices that you had. If we look at firewall categories by structure, most firewall appliances are standalone, self-contained systems, and then they come in a bunch of different grades, where you have commercial grade firewall systems, small office, home office firewall appliances, and then residential grade firewall. So there's just another way of categorizing them. And which firewall that an individual or an organization chooses is really, dependent on some circumstances. So some questions that you would have to ask yourself. Where would you rather defend against the hacker? How far away do you want to put that gate up between the untrusted and trusted network? With the software option, if you're using software-based firewalls, and there's certainly nothing wrong with them, so there are some really good ones, and matter of fact, most Windows machines come with a firewall already installed on them. But the concept being is that if you're going to use software-based firewall, your perimeter, which you're creating with that firewall, is at the machine that you're trying to protect. If it's not correctly installed and correctly configured and correctly patched and upgraded and designed, once they defeat that firewall, there's nothing else for you as a network security professional to put between them and that machine, because the software for the firewall is sitting on the machine that you want to connect to. Think about it as at home, a home user relying on a Windows firewall. That is their line of defense, and their line of defense is the computer which they're protecting. So when that firewall is defeated, then there's nothing else between them. With hardware devices, even if the intrusion manages to crash the firewall system, your computer and the information are still safely behind what is now a disabled connection. If you configure your firewall to disable the connection in the event that it somehow fails, in essence you've isolated your network and you've cut the connection off, so you've pushed the evildoer, the would-be evildoer, back outside your network. But again, it's a decision that organizations have to make. Some organizations would prefer that when their firewall fails, it fails wide open, which means in the event that the firewall crashes, the network becomes entirely open. And that's a business decision that they would have to make, and a lot has to do with how reliant they are on maintaining that connectivity.